Hello everyone, welcome to today's SolveTree webinar. We're going to focus on as-built estimation and quantity takeoffs. Before we get started, here's a bit of housekeeping. For those of you here in the live version, please ask questions and engage with us through the Q&A section of the GoToWebinar panel. We'll address all the questions at the end of the webinar as usual. Okay, so today we're going to focus on as-built estimation and quantity takeoffs, and there are a few reasons why you might be doing this. First, as-built can serve as a record of construction for performance or conformance to your design. Second, they're great for helping you quantify volumes, for example, for payment purposes. Okay, so for today's agenda, we're going to start simple and work our way up in complexity. We will start by calculating the volume contained in a single surface. This is commonly done for stockpiles. Next, we will calculate the bulk volume between two surfaces. Common applications for this are used in site design, quarries, stockpiles, and etc. Finally, we will get to much more complicated as-built estimate by calculating volumes by chainage for a piece of linear infrastructure by surface layer, including stripping, undercut, and final grade. And with that, I will pass it over to our resident webinar expert, Matthew Dickey.
Well, thanks for the introduction, Andy. And yeah, we'll keep rolling along. Before I jump over into the software, we'll just kind of touch on a bit more of the concept for what we're covering. So the first item, the calculating volumes in a single surface, pretty straightforward. If this is a cross section of the area we'd like to deal with, we're going to just delineate around the feature that we'd like to look at, and we're going to calculate the volume within that single surface. So basically, if it was interpolating a surface underneath there to give us a volume. The next one, calculating bulk volumes between two surfaces. That's if you have some more complex topography, or if you're and have one survey before construction, one survey after. Then we're going to do compare those two surfaces and see what our volumes are. Yeah, so common and for a lot of different uses. And then the last one that we have that we're going to cover today is looking at our volumes as they relate to a piece of linear infrastructure. So looking at that by chainage and using different layers for those quantities. So here we're going to start out with our topo surface, add in our surveyed stripped surface, add in our surveyed final subgrade, and then we're going to look at our subcut. Now, yeah, as Andy introduced, it's going to start out pretty straightforward, and then as we get into this stuff, there's a couple items that a little less intuitive, but pretty easy once you know how things work. So with that, let's get out of PowerPoint and jump into the software. So something that many of you, if you're familiar with the software, will be well aware of it. The software is modular, so we're going to tackle building our surfaces from our survey data and terrain, and then when we get to doing that road-specific stuff or linear infrastructure-specific stuff, we're going to jump over to the location module. So I'm going to start out in terrain, and this stockpile example that we have, I'm going to use a LiDAR data set. And for this, it's the project straddles 4 tiles of LiDAR data, and I don't really care about the majority of that LiDAR data, so I'm going to thin it down based off of an area of interest. So I've just brought that in as a shapefile. And here I'm going to tell it that within that polygon, I don't want to skip any of my points. And then outside of that polygon, I want to skip everything. And it's just going to take a moment to read that in, and yeah, once it's read in, we'll model our surface and contours. Yeah, so just a couple housekeeping items while we wait for this to calculate. Everyone's audio is turned off, so if you're trying to talk, I can't hear you, but we do have the question panel there. So if you'd like to ask a question, it remains, we won't identify who's asking what question, and we'll answer those as they come up or at the end. So if we have a little moment for calculations, we'll tackle them as we go, and then if not, I might not notice them until we get to the end of our presentation. And we should have one more tile to bring in. Oh, and just to see the question about are we going to work with other data sets other than LAS? And so the LiDAR data, absolutely. So in this, depending on what we're looking at, it's either going to be LAS or total station data. We've got different formats for the total station data we'll work with today. But yeah, we can work with all sorts of different file types. So our LiDAR data is in. I'm just going to model our surface now. And I want to include contours below 0 for this one because it's a big hole in the ground. And yeah, so just to elaborate on that question about other formats, LAS, great format for your true LiDAR data, also a common format if you're dealing with photogrammetry elevation data. Then another common alternative is DEM data, which we support quite well. It's workflow for that's very similar to LiDAR. And then when we get into the total station and other conventional survey methods such as RTK, we can set the software up to automatically ingest that survey data to suit how you prefer to collect it. And we'll talk about that here in a second. So there's our LiDAR data. I'm going to click the 3D view just so we can get a better feel of what's going on. And we can see we've got our quarry and we've got a few stockpiles over here. So let's say we wanted to know how much volume we're in a couple of those stockpiles. So let's look at this one and this one. If we zoom in here, you can see this contour is pretty close to a reasonable limit for that. We could go a little further to get a better estimate. So that's what we're going to do. Now, for the little further, I'm just going to come in here and I'm going to buffer this. So I'm going to offset it an additional meter. And I'm going to tell the software that I want this to be a draped feature and I want it to be a surface volume boundary feature. So I'm going to name this pile 1. And just so we can keep track of things, I'll change our line type. And we can do the same over here. Now, just for the sake of mentioning it, we could also draw a polygon around this by hand. But since that contour does such a good job at delineating what we need to see, I'm going to go that route and buffer. Same thing, I'm going to name it so we can keep track of what's what. We'll drape the line, surface volume boundary, and once again, we are going to just change the line type so it's easy to tell what I'm talking about. So we've got that. Now to figure out our volumes, we'll click calculate volumes, and we'll just do a volume enclosed by a single surface. And we'll separate those by surface properties by polygon. And There we are. So we can see pile 1, we've got just shy of 7,000 cubic meters, and pile 2, we've got just shy of 5,400 cubic meters. For what's tabulated as cut and fill, you can choose what's what here. So if you'd rather that noted as a fill volume, we can absolutely just switch what's referenced. So that's one item. I'm going to save this. And let's run through a different scenario where we've got, say, LiDAR data was shot a while ago, and we want to keep track of our progress opening up this pit. We've extended out the excavation for the pit floor here, and we've surveyed it, and let's compare those two surfaces. So for that, I'm going to open up another instance of terrain. And I'm going to click Insert File. So this data set is a conventional survey data set. So just to see what we're dealing with, this one's set up. We've got our point number, coordinate, elevation, and point code. So for that, rather than having to format how that's suggested every time we open the software, we can build an IOP. And an IOP is just a matter of clicking New Format and telling the software, I want my X column to be column 2, Y column to be column 3, and my different point codes to mean different things. So I've already got that done here. As built pit is what I've called it. My X is column 3, my Y is column 4, my Z is Y is column 2, Z is column 4, and point code is column 5. And my code, I've got TOC being brought in as a black line with a cross symbol at each point, BOC similar, dashed line, and then both of these are break lines. And then final ground is just my ground shots. Those are going to be brought in as points. Now this wouldn't matter because they're brought in the same data set. I'm just going to set that projection. It's a best practice more than anything else. We'll hit OK. And there's that. Now I'm going to model this surface just the same way I did as the LiDAR data. Now for this, it's going to be a lot quicker just because there's a lot less points. And there we are. Now here, I don't care to calculate that. That's a bad triangle in that case, so I can just set this property to be a boundary feature. So, pin boundary, also change our line work, everything that we have over here. Up until now, I've been using the hotkeys on my keyboard to open up the same options. So that's now a boundary. I'm going to recalculate, and we've limited where that surface is created. Now to compare the two surfaces, we can go up to calculate. We're going to go volumes between two surfaces. We are going to reference that topo surface that we've just created, and we'll hit OK. It's going to take a moment to think. And we can see we've got a whole bunch of fill in this case, and that's just a matter that this topo surface is my final, that's my original. So we've got a whole bunch of cut and a little bit of fill. Now, if we want to see what's actually going on there between the two surfaces, we absolutely can. I can right click my 3D options, add in a background. And I'm going to make it so we can see that other surface. I'm going to make it so that other surface is transparent. So I'll do that in my alpha channel. And there we are. And that little bit of fill that we had in there, it's just kind of a matter of between the LiDAR and whatnot, there's been some things moved around as the excavation took place. So there's not a big gap there. Yeah, so that's kind of our bulk excavations. Now the next one is our road stuff. So the road stuff, we're going to start out in terrain for that to build our surveyed surfaces, and then we're going to keep track of them in location. And I'm going to click Insert File, and we'll go Let's build a road. So for this, we'll start out with our original ground. Now, here's a case where my survey data is brought in a different format, so I'm not going to use the same IOP. This one's set up to skip the first two rows because there's no coordinate data there. And then we've just got X, Y, Z, and our point number. So we'll bring that in. And there we are. I'm going to create my surface. Now, pretty small site. I'm not going to worry about creating contours for this. Do that. We'll check out our 3D. Now here's a case where I could take the time and I could draw in a tin boundary feature if I'd like. There's other options to limit where that surface is created. And the one I'm going to use here is just limiting the maximum side length of my tin triangles. So if I set that at 30 meters, no triangle edge can be longer than 30 meters, and that looks pretty reasonable. So I'll hit Save As, and let's call this OG Topo. We'll do the same for another surface. Insert, and let's grab our final grade. This is final subgrade in this case. We'll use the same option. The two are formatted the same way. We'll hit OK. There's that. Terrain modeling, generate. We'll see if that length is a reasonable amount. There we are. Now, I'll just mention this for the sake of time. I'm not going to do it. If I wanted to go in and add in my line for my shoulders and center line and whatnot, if I wanted to see that graphically, we absolutely could. It doesn't take too long, but I am going to be pressed for time to fit everything I want to fit in. So we're going to just use that. Another thing we can do to keep things straight is tin operations. If I want to see a limit of where my surface is, I can go create tin boundary feature and see that there. So I'm going to hit save, and we're going to call this final subgrade. We're going to hit OK. So let's jump over to location. Now, if we had a design that we've already completed in location, we could do all this in the same design file. In this case, I'm going to make some different assumptions and assume, say we only had the alignment for what's supposed to be built and our survey data. So we don't have the raw design files. I'm going to reference my original topo. Oops. For our alignment, we could start and just click something in by hand after we bring everything in there. Now, in this case, if we have the alignment provided to us, we can bring that in a few different formats, one of them being XML. There we are. And here, since I'm not designing, I don't need to automatically generate any cross-section geometry. I'm going to use my survey data for that. I'm going to start out with an empty template. So my roadway is just going to be a center line. So there we are. Now a quick kind of housekeeping item. This design alignment extends out past where my my survey data starts. So I'm just going to, it wouldn't affect anything. It's more of a preference thing on my end. I'm going to get rid of the stuff we don't have survey data for. All right, so there's our original ground, and we'll add in those other surfaces. I'll click properties, reference drains, I'll come down here, and let's grab our stripped ground. Oh, and So there's a couple of these files that I just did because it's all repetitive. So our stripped and our undercut surfaces I already had created, but the workflow is the same as the other two. So we'll go stripped, we'll bring that in. I'm going to tell it that I want that to be brought into surface layer 16. We'll make surface layer 2. Let's make that our final subgrade. We'll make that subgrade material. And then we'll do our undercut last. And we'll make that surface layer 15. So we'll hit OK. We'll hit OK. Now nothing's happening out here where we're not on the actually built section that's surveyed, but we can come in here and then we start seeing a bunch of different lines. So we can click around and we can see that right now we are calculating volumes. I've got my cut volume calculated for subgrade. My strip layer is being calculated first, so that's good. But if we come into our undercut, I'm going to just turn on hatch all for undercut. So here, it's not just calculating our removed and replaced material, it's extending right up to the top of the merged surface. So I'm going to do some tidying up on my end, and I'm going to use our fixed sections for that. So there are different ways you can tackle these linear infrastructure as-builts. You can use templates where we set up follow surfaces to reference different reference features. Generally for as-builts, the fixed sections are easier, and you don't need that added logic and smarts built into a template, since you're just dealing with what's there. You're not looking at, if I move this over, how does that change interact with the road geometry. So I'm going to click our section editor. I'm going to add sections, and I'm going to do my whole road. There we are. Now I'm going to come in here and let's just click through and see what's what. So I'm at station 13900. Open that up so I can see my topo surface. My surfacing 16 layer is in there. Then we've got our subgrade, and then we've got our undercut. Now for our surfacing layer 16, I suspect there's going to be somewhere in here where my surfacing layer is, oops, above my topo surface. So an error surveying, you're not filling with stripped material. We can clean that up. So we're going to go in here, we're going to click operations, and I'm going to tell it, let's do a minimum between two layers. So a minimum between surface layer 16 and surface layer topo, and we'll make that our stripped layer. I'm going to apply that to all our sections, and let's do it across the board. So there's that. Now they're down below. Now there is a draw order here. So right now, if I want my strip layer to be calculated before my subgrade, which I do, I'm going to shift this up. And this surface layer 16 is no longer useful. So I'm going to hit remove on that. I'm going to remove that for all. So we've got our stripped, that's good. I'm going to apply that to all just so everything's shifted up. And yeah, so we've got our stripping taken care of. Our subgrade is being calculated appropriately, and the next big thing being our undercut. So if we, just touch on it again, if we hatch our cut for our undercut, it's going right up to the top of our subgrade. So I'm going to add a another layer in there to intercept that, to isolate what's considered subgut, and then isolate our undercut. And for that, let's go operations, minimum between subgrade and stripped. We're going to add that in as surface layer 14. And there we go. Now I'm going to turn this off. Oops. And we're going to do that in here. So that's surface layer 15. I'm going to shift that up. And I'm going to open my sections options, come in here. So surface layer 14, surface layer 15. And let's change our line type. So let's make that, oops, change our hatch. Let's make that. And there's that. Don't want to see 14. 14 is just a temporary layer showing me, acting as a barrier so we don't double count our volumes. So right now, our volumes are being calculated appropriately. Our mass hauls keeping track of our subgrade, movement, and surplus. So we can see right now we've got a surplus of 3,000 cubes. And if we want a tabular breakdown of what's going on in all those other surfacing layers, or all those other surfaces for volumes, we absolutely can. We can come over to our data table, data options. I'm going to remove those and let's add in, we want to see our cut volume, fill volume, our stripping volume, and there's that. Put design totals at the bottom. And let's look at a summary in 20 meter intervals. And we could change that to be whatever we want, but 20 meters seems reasonable to me. And there is our excavation summary for the project. Yeah, so that's the meat and potatoes of what I wanted to show today. I'll just jump ahead. I'm not going to set it up from scratch. If we want to do just a design comparison to see how well we adhered to the design, we can absolutely have your design and we can add in a reference surface to see how the two compare. So here's our design with our normal template. So that template is smart. And then I've added in this, where's it at? This reference terrain, so final grade, I can see where it is. I'm not worried about calculating volumes for this. I just want to be able to see where those that surface is compared to my design surface. So there's that. We can click along here and yeah, you can see there's always going to be a little bit of deviation between the design and what gets built. So I see we do have a bunch of questions here now. Let's I guess start from the top. There's a question related to LiDAR points. One of the reasons I thinned my LiDAR data down on import is the bigger the data set, the slower things get. So we recommend folks try and keep their data set to be under 10 million points. So that's an instance where you'll, if you focus in on what you need, you're going to have faster computing time. And for this question, I should have been more clear for what I was referring to there. Just to clarify, topo survey is what the area looked like prior to the excavation. In this case, our topo survey is both the survey for original ground and then the survey for our as-built, so that the final survey or in progress survey. Regardless of what the survey represents, the workflow is largely the same. It's just you need to build that surface to represent either your original ground or what's been constructed to compare the two. And that one, why not show the comparison through the calc volumes? Oh,
sorry, Matt.
yeah.
If it's okay, could we go back to the first question and actually read out loud what the question itself was?
Which one?
The first question that you've answered, I think we've missed to address what the question was. Could we just read out loud what the wording of the question, I guess, so to say?
The LiDAR question point?
Yes, please.
Okay, that one was just it was a comment about the number of points that I brought in there. So it wasn't a direct question on it. I was more just speaking to what the comment was. So it was.
Okay, I see.
It was 1.5 million points, and then with a smiley face. So yeah, not really a question, more a comment. Just speaking to the context for what the comment was coming from.
Sounds good. Yeah, just wanted to ensure that we're covering and addressing all necessities. Yeah.
And yeah, so the topo survey can be a topo before or after construction. Why not show the comparison through the calc volume screen? So that was, I don't know if I still have it open. So yeah, here I briefly showed it. So my calculate volumes, I'm going between my topo and my current surface. Now I could recalculate it, take a moment. But there's the volume summary for what we're dealing with. So I turned on the 3D view just to see kind of explain away why there's a fill volume, where if it's a big quarry excavation, you expect it to all be cut. And it's just a matter that the floor of the pit must have been raised a little bit as they're moving material around there. And we've got a question, can I hatch the color or color the different areas of the cross sections to make them easier to understand? So absolutely. And I think that's coming back to our road design or road example. And I think that question was asked before I did it, but I've hatched my undercut there so I can see exactly what's being calculated with that. And then zooming in here, I can see that I should have been a little more careful. My undercut should be the minimum of my values here. So for that one, we can come in here and do that operation where undercut is the minimum of our stripped and surface layer 15. And we can read that back into B surface layer 15. And there we are. Another thing, just while I'm making tweaks here, another nice thing with our fixed sections is if there's anything that you want to manually change, we can come in here and we can, physically draw in or change our lines to suit. So if you have a bad survey or a bad point or just a bad cross section that you don't want to be rendered exactly the way it was surveyed, you can tackle that either by hand in our fixed sections, or you can go back into your surface trains and modify the modeled surface. And we've got a question about, is there a list of hotkeys available for RoadEng? It looks even faster with them. So I'm a big fan of the hotkeys. We don't have an explicit list for them. Now, most of those hotkeys, if I click around here, actually I'll show it in the train. If I click in here, modify selected features, as I narrow in on the different items that I want, it's going to tell me what the hotkeys are. Same with select. Anything as you narrow in on it, it's going to tell you how to do it with the keyboard if there is a default option for it. And you can customize it too if you really want to have it suit personal preference. I'm not going to show that to the the vast majority of the group, just because if the folks ask for help, then the hotkeys we won't use might not work and save a little bit of confusion. But if that is something that is something you'd like to do, just reach out and we can show you how to customize those hotkeys so you can change the commands. Okay, so we've got how would you like to graphically edit a surface to ensure closure? So we've got the operations, we can do it by hand, and another thing we can do, and let's see here, do we have any, just gonna look for a bad point. Well, I'll force one. So here, if I come up here, and if I'm in fill and I want to force that to close, I could manually change it to close, or I can tell the software to close by layer properties, subgrade, and I can tell it to auto extend. So set our cut and fill slopes to be whatever we'd like. And why didn't that work? I guess it's, layer properties, subgrade, auto extend. So usually we can, and for some reason it's not working for me. The answer is yes, and I don't know if I'm just drawing a blank or if I found something that might be because I've modified it. But the answer is yes. I'll have to get back to you on the actual solution there for that. Next one, can you show an example of a method of tying off final surveyed surface to original ground in cross section, like how you extend an individual line? So yeah, we'll circle back on that. It's similar to the previous question. We'll reach out to you guys, and yeah, so there's a way to do it in here, and for some reason I'm drawing a blank, or it's not behaving for me, and then there's another way to do it in the terrain module where we can set the terrain grade out from our surfaces to another surface. So both are useful, both have their place. And we've got, you guys used a stockpile to calculate the volume in a single surface. Is it possible to do that with just an excavation survey? Yeah, so if it was the opposite, if you just wanted to know the size of your hole, you could do that. Now, the limitation of going with that approach would be if you have an irregular original ground surface, it's going to interpolate the volume based off of an interpolation based on the boundary. So if you had if you dug a hole and the hole was originally a mound of dirt, if you dug a hole, it's going to project that volume being a planar surface around the extents. And yeah, I think we're a bit over time. Did better than what I thought I was going to do for time. And for those of you that I left you hanging for a solution there, I will we will circle back and reach out directly, or possibly add the correct answer in the video, which will be posted to YouTube afterwards. Excellent. Well, thanks everyone.
Thank you. Have a good day, everyone.